Trufan, and in this video, I'm going to show you how to make Rochelle salt. For the Rochelle salt synthesis, you will need some sodium carbonate. You will need some of your recrystallized cream of tartar because we want to make sure that the cream of tartar is pure or the potassium bitartrate is pure. You will need some deionized water because these two starting materials will be combined in the presence of water and you will need to boil it for some time. In order to make this happen, you will need a 50 milliliter graduated cylinder to measure the amount of deionized water, a 100 milliliter beaker to conduct the experiment in. You will need to boil your water and you will need to stir it. So if you are doing the experiment in a chemistry lab, you will want to use a hot plate and magnetic stirring. Otherwise, if you are at home, perform the experiment in the smallest available pot on the stovetop at medium low setting. Here I have a hot plate and stir plate, and I have some magnetic stir bars. To record the mass of my starting materials, I will use a scale. I will measure my cream of tartar directly into the beaker, and I will measure the sodium carbonate amount into a weighing boat separately so that I can make adjustments if I add too little or too much. And I'm going to use a spatula to make those adjustments. Let's get started. I will turn on my hot plate to get it warmed up for my experiment. Next, I am going to turn on my scale, place my 100 milliliter beaker on top, tare it, and then take my recrystallized cream of tartar and transfer it into the 100 milliliter beaker. I want to transfer all of my material here. And then I will record its mass. It is 16.61 grams. From there, I am going to use stoichiometry to determine how much of the sodium carbonate is necessary. For every 1 mole of the potassium bitartrate, I will need half a mole of the sodium carbonate. So for me, that means approximately 6.7 grams of sodium carbonate. So I will take my weighing boat, place it on the scale, tare it, and then use my spatula to measure as close as possible, but maybe slightly under the 4.7 grams. And I measured 4.67 grams of sodium carbonate. I will set my chemicals to the side, and now I am going to combine my two starting materials into my beaker. From previous experiments, we may know that the cream of tartar is notoriously difficult to dissolve at room temperature in water. And we know that because we tried to recrystallize it, and it took us a long time to get it dissolved, and it would not dissolve until it was boiling for some time. So that means our experiment is going to give us visual clues as to when our cream of tartar has transformed into the Rochelle salt, which is the sodium potassium tartrate. We're going to use some stirring. So I will take a stir bar, place it in my solids, and then setting my scale to the side, I will measure 35 milliliters of the ionized water. This doesn't have to be very exact because in the process of the synthesis of Rochelle salt, we are going to boil our solution for some time. So it may be that adding a little bit more or a little bit less of water is acceptable. There will be a little bit of fluctuation as some of it boils away. But just to know where we start, we have poured a volume, and in my case, the volume is 35.4 milliliters. I am going to transfer the deionized water into my beaker. Give it a gentle swirl. And depending on how large or small my potassium bitartrate or cream of tartar crystals are, I may observe a little bit of fizzing or a lot of fizzing. If you're using powdered cream of tartar for this experiment, there will be a lot of fizzing all at once. Otherwise, it may be fairly gentle because the crystals are slow to dissolve and only what dissolves will react. If your fizzing is not overwhelming, you may place your beaker onto your hot plate and begin stirring and heating. Here I have my hot plate. I already set it to a gentle heat. And then I'm going to turn on my stirring. I want to keep it rather gentle at first. And then from there, we can adjust the stirring and we can adjust the heating. What we're aiming for is manageable amount of bubbling. We need to keep doing this for at least an hour, but we will know when this reaction has completed because everything is dissolved. Rochelle salt is very soluble in water. Cream of tartar is not soluble or sparingly soluble. So when all our cream of tartar is completely reacted, we should see a clear solution. So this seems to be chugging along effectively. We can keep this going at this rate for some time. If the bubbling slows down, we may want to increase the temperature gently, little bits at a time, or adjust the stirring. It has been approximately an hour since we started our Rochelle salt synthesis, and because our solution has been boiling quite vigorously for some time, we find that our solution turned clear, which can only mean that all our cream of tartar reacted with the sodium carbonate that we mixed it with, and now we have the sodium potassium tartrate in our solution. It is still relatively hot, so we want to operate with it very carefully. Because the next step is to grow crystals of our Rochelle salt, we are going to turn off the stirring and we're going to turn off the heating, slowly cool our solution. Now that we turned off the stirring and the heating and our solution has cooled off just enough for it to be touchable, we're going to bring in a 15 milliliter beaker and a pair of tweezers in case it is necessary. But we're going to take our 100 milliliter beaker and pour over our solution of Rochelle salt. If the magnetic stir bar slides over, we may want to stop it. And if it goes into the 50 milliliter beaker, then we can use the tweezers to get it out. Now that we transferred all our solution, it is still somewhat warm, so we're going to let it stand for about 24 to 48 hours in the hopes that it will produce reasonably sized seed crystals that we may use to grow larger crystals later. It has been approximately 24 hours since we completed the Rochelle salt synthesis. It boiled, it turned clear, and then once we achieved a clear solution, we let it settle. And then as it rested and very gently cooled down in the course of the day, we noticed that on the bottom of our beaker, we have a lot of little crystals. Now we want to grow some of these little crystals into large crystals. And because we have a fairly small amount of solution, we want to grow these crystals in a small beaker. For the purposes of this experiment, we are going to use a 15 milliliter beaker, so it is rather small and compact. We will extract some crystals, dip them in some deionized water, and to complete those extractions, we'll be using a tweezer. So the first thing we're going to do is use our saturated solution of Rochelle salt, which we know we have here because on the bottom we have the crystals, so they have to have grown from saturated solutions. So I will take my beaker with the solution and the crystals on the bottom, and I will pour over the solution from the top. If crystals start coming, I will simply stop pouring. I want to get as much of my solution out as possible. Once I got there, I have my gross solution. Next, I just need some crystals to grow from it. I will take my tweezer and extract crystals that look smooth and shiny, and these may be relatively small. As I select my crystals, I will put them in the beaker with the water. It will rinse off a little bit and it may reveal some imperfections. If I'm not happy with the crystal, I will set it back. If I'm happy with it, I will place it in the growing solution. This particular crystal looks really clear. Now let's find at least 2 or 3 more so that we can have our choice of which crystal we want to grow real large in the course of the next couple of days or weeks, depending on how well the crystals grow. This looks pretty good. This one appears rather large and pretty clear. I don't want to keep it in the water for too long because it will dissolve. And then I will add one more crystal. You may add more or less. 4 is a good number to start with. It gives you choices. But if you add a lot more than 4, then your crystals will be competing for growth, and then none of them will grow too big. The final step is to look into your growth solution, find your crystals, and make sure that none of them touch the walls of your beaker or each other. So just like you place your cookies on a baking sheet, put them as far away as possible within a reasonable amount of each other so that as they expand and grow, they don't overlap and cause imperfections in each other.